today we are going to study about again the domain and range of our functions, but this time our function is in the graph form. Domain and range. We know that the domain are the x values and the range are the y values. Now, how do we test for the domain? To find the domain of our function in a graph form, then the vertical test will give us the domain of our graph function. Now, how do we do the vertical test? To do the vertical test, we use a vertical line, and if that line intersects our function, then we have the domain for that function. If the line does not intersect the graph of our function, it is not the domain of that function. What about the range? How do we test for the range of our function? We use the horizontal test. This one. The range is determined by or tested by the horizontal line test, in which we are putting this one in the y-axis, and we are going to find the values there. If this is a line and this line intersects our curve or function, then there is a range there. If the line from this one does not intersect any part of the graph function, then it is not the domain of that function. So here, this is our x-axis. So the x values from negative infinity to positive infinity, those are the x values, and those numbers are the domain of our function. Now, to test that one, we need the vertical line here. So if you have a vertical line here, now is the vertical line crossing or intersecting the function? No, then this one is not included in the domain. This one like that. Okay. How about the range? The range is like this one. So, do you have a range of this function here? Yes, because the line here, the test line, the horizontal test line intersects this one. Therefore, this value here is equal. Let's have first the vertical line. So we have here the y-axis, and the y-axis also has a negative infinity down and a positive infinity up. And this is the range of all real values of our y-axis or the range. Now, this one is the origin, the intersection of the x and the y-axis here is the origin. This is our vertical line. And what is the equation of our vertical line? That is x is equal to 2 here. So 1 and 2, and then we draw a vertical line. We will determine the range and domain of this vertical line. So to check the domain of this vertical line, we will use the vertical test. Vertical. Right, start here. There's an intersection because our line is here. No. And no here. And there is only one intersection. And that intersection is with the line itself. So what is the domain? The domain is, what is the value here? That is 2 here. Therefore, there is only one domain of this vertical line, and that is the positive 2. The x value of 2. That is the domain of our vertical line. The range is the y, and to determine that one, we need the horizontal test. So if we are going to start here, is the 0 part of the domain. We are talking here, class, of the 1 here, the 2 here, the 3 here, negative 1 here, negative 2, down to negative infinity. So 3 is 3 included in our domain. We have a line, and this line intersects here. Yes, the 3 is included in the range of our function. 2 is 2 included also? Yes, because if we are going to draw, we will have intersection here. 2 is included, negative 1 is included, and 0 is included, negative 1, negative 2, up to negative infinity, because this line does not end here. So here, all of this will be the range of our vertical line. So the range is all, what is this one, class? Real. All real numbers. All real numbers, not only real numbers. We have to specify that one is the y values. So the range of our vertical line is all real numbers, or all real y values. Or we can say that the range is from the negative infinity, from here, from below, going to the top, to the positive infinity of the y-axis, not the x-axis, because that's for the main. Okay. Now let's have the horizontal line. The horizontal line equation is y is equal to 3. This is our equation. And this is our line, horizontal line. This one is the x-axis, this one is the y-axis. We have negative infinity here, negative infinity here, and we have the positive infinity there. Alright, x-axis negative infinity and the positive infinity. Now let us check the domain. What do we do with the domain? We use the vertical line test. So here is the x-axis, and we are going to use the vertical line. If the vertical line intersects our function, then that value there is included in our domain. So here we start from 0. Is this line intersect this one? Yes. What about the one here? Will it intersect that line there? Yes. What about the 2 here? Will it intersect there? Yes. About negative 1 here? Will it intersect the line there? Yes. Negative 2, negative 3, negative 10, negative 100. Will it intersect there? Yes. If it is yes, therefore all the values here of the x values will be included in the domain. Therefore, our domain will be all real numbers, all real x values. Okay. So domain is equal to negative infinity, comma, to positive infinity. If you are going to use that one, the interval notation. What about the range? The range is, we are going to use the horizontal test. So for the horizontal test, you have to start here. Does this horizontal line intersect any of the part of our line? No. Here, no. Negative 5, no. Negative 2, negative 1, no. 0, no. 1, no. 2, no. 3, yes. It intersects the line in the line itself. Therefore, our range here is 3. This one is the y value. It's the y value only 3. So our range here for the horizontal line is only 3. Domain all. So we can see now the difference between the domain and range of vertical line and horizontal line. Okay, we have now again the vertical, but this time this is not a line, but a line segment or array, and also for horizontal line segment or horizontal ray. So here, last, we have the origin, the y-axis, and the x-axis. Negative infinity to positive infinity up. So we have our line segment here, and if you notice, the end of our line segment, the meaning of this one is not included. It's unshaded circle, like in our linear inequality. So this one is not included. That end there is not also included because they are unshaded circle. So our line is from here only, from here, not here, from there, and from there. So let's first get the domain. Again, how do we get the domain? We use the vertical line test. So we get our ruler or straight x, and then this is our x-axis. Then where is that line? This line must intersect that graph of the vertical. So where's that one? This is not, because this one's the y-axis. And here. So our vertical line intersects the line itself at x is equal to -3. Therefore, our domain is -3 only. And this one is the x values. X values. Or x value if only one. Now, what about the range? The range test is the horizontal. So, we need the line to intersect our line segment. So if we are going to start from the bottom here, the negative infinity here does not intersect anything. Okay, then the -3 is the end, but the -3 is not included. Therefore, you can use the range like this, means not included, and you write the -3 here. The -2 is included because this line will intersect this vertical line here until the 4 here, in which the 4 is not included also. So we write here the 4, and then we write the parent, the close parent for parenthesis. So we have this domain and range. Okay. What about if this one is shaded? This one is shaded. So again, the domain will be the same. -3 is our domain. The range now will be different. -3 is the -3, but when we are in the 4 already, it is shaded, means it is included. The line segment is up to there, up to that point. Therefore, we will just change this one to include the 4, in which the symbol is a square bracket, and you can put here, these are the y values. Okay. What if this one is also shaded? It means it is included here. So again, the domain is the same, -3 only, but the range will be different. What will happen to the -3? It will be included now. Therefore, we'll just change this open parent into a square bracket here. What if that is array? Okay, let's have array here, and our A, the arrow is here. This is pointing up. And the endpoint of our array is at -3, still shaded. Careful. Always take note if it is shaded or unshaded. So, what is the domain? Still the domain is the same. Because if you are going to use this vertical line test, it will just intersect only here, -3. So the domain will not change, only. Alright, from the bottom here, the negative infinity is not included because if you are going to have our horizontal test here, then it will not intersect this ray. So it will intersect only here on the -3, and -3 is included. Therefore, here is the symbol, and we have a -3 here, and it goes to, it does not stop at 4 or 5 or 6. It goes through up to the positive infinity, and there it is, positive infinity. But the infinity, they are not included in our domain, so we write like this. Okay. What if this one is unshaded? If this one is unshaded, means you will just change this square bracket into an open parent. Like this. Okay. If this one is shaded and it's going down, if it is shaded, then you put there, you start again from the -infinity. Right? Here is, let's have excluded point there. Okay. And this one's going down. So the domain will not change, only this one. Okay. Now, if you have arrow going down, in our interval notation, we always start from the smallest, from left to right, or from bottom to top. So this one's going all through the -infinity, then we need to write first the -infinity with this one. -infinity going to this one, but 4 is not included, therefore it's like that. If this one is shaded, it means it is included, then this one will become a square bracket. Okay, let's have the horizontal line segment. This one is the origin, the y-axis, the x-axis, and then we have here our segment. The ends here, the two ends are not included because they are unshaded. So we need to find the domain. So vertical test, domain, here, no, 4. Is 4 included in our domain? No, should be less. Right, 3, yes, -2 included? No. So how do we write the domain? Start from here, going here. Is -infinity included? No. Is the positive infinity included? No. So we start here. So we know that this one is not included. The -2 is not included. Not included. And then we put the -2 goes to 4. Is 4 included? No, unshaded. Therefore, we have this one. That is the domain. Now let's have the range. The range is horizontal test. So when we test it, it intersects only at this point 3. So our range here is 3, positive. Do not put there the parenthesis or the square bracket. We use the set notation here, this interval notation, and then you write that this is the y value only 1. Okay, now let's have one of them is shaded, two of them are shaded. Okay, so when these two are shaded, it means this is the end of our line segment, and that point is included. They are both shaded now. What is the domain? Now the domain will change now. Instead of this open parent or the closed parent here, it will be changed into bracket, y square bracket, because this negative 2 is now included in our domain. So this one will change into that one. What about the 4? The 4 is also shaded. It means it is included. Therefore, this one is also like that. This one is our x values in interval notation. What about the range? The range is still 3. Okay. What if we have an arrow? So here, let's have an arrow here, meaning it is continuously going in that direction. So we have like that. So here, class, we should write negative infinity because our line is going to the left forever. So we have that one there. Alright? Now let's have the domain. So the domain here, this one, even though this one is going to the left, we will first write the negative infinity. And here, for the domain, this one is always parenthesis, an open parent here. And we write the negative infinity here. Negative infinity. And then it will just stop here on the 4. So we have the 4 here, and 4 is included because it is shaded. Therefore, I'm going to write like that. That is the domain of our array. So raise the same. The y value is 3 for our array. Okay. Now, if that one is going to the right, okay, start from 2. So this one is not included. Okay, and then this one, you cannot stop here, goes through forever to positive infinity. Then we start from here, going to the right, to write the interval notation. And then this one is negative 2. It's the open parent because negative 2 is not included here. So we will not raise the open parent here. And I'll put the negative 2 here. It goes not only to 4, goes forever in the rightmost direction here. So I'll write here is positive infinity, up to positive infinity. And that is how to write the interval notation. And this one's the domain, the range of our vertical lines, vertical line segment, vertical rays, and then this one's horizontal line, horizontal line segments, and horizontal rays.